I would like to welcome you in this new chapter where we're going to be learning about STL containers and iterators. Now, STL stands for the Standard Template Library, and it is a collection of tools we can use to make managing collections of data easy. It has three parts. We have containers, which is a set of collection-like types we can use to store collections of elements. And we have built one of these things. Actually, we have built a box container class, which we could use to store collections of different types. We could set up a box container of integers. We could set up a box container of dogs or cars. We could really do all kinds of crazy things. But the Standard Template Library provides a wide variety of container types that you can use. And each of the containers you're going to see is really going to be specialized for different tasks, as we are going to see as we progress in this chapter and other following chapters. We also have iterators, and iterators are pointer-like types that we can use to navigate through our collections. So for example, it is going to allow us to loop easily through collections in a unified way. So if we have one collection, for example, and another completely unrelated collection, we can use the same mechanism to loop through them and access our data, be it for reading or writing, and you're going to see how all these things work. The Standard Template Library is pretty powerful, and you're going to see that it is going to make your job easier in your daily job as a C++ developer. The last part we have is algorithms, and these are a bunch of functions we can use on our collections to do all kinds of crazy things. For example, we might want to sort our collection, we might want to find something, we might want to do all kinds of crazy things, and we can achieve these things fairly easily using standard algorithms that are built into the Standard Template Library, and we're going to learn about a few of these. So let's look at each of these things separately. We're going to start by looking at collections or containers, and I am going to give you an example of what we have built so far. The main goal of setting up our box container class was so that we are able to manage collections of data fairly easily. So for example, we could set up collections of things, we could store in integers, we could store in dogs, we could store in cars. And we had the ability to set up a bunch of methods that we can use to manipulate this collection easily. We had the ability to add items. We had the ability to remove items. We could set up a bunch of operators. For example, the compound addition operator would add up two box container objects. We had the addition operator. We had the stream output operator. We could really do all kinds of crazy things. So what we're going to see in this chapter and other chapters to follow is that we have built-in collection types that we can use without having to set them up ourselves like we did for box container. And we have a bunch of options we can choose from. Some are going to be good for some applications. Some are going to be pretty bad. So you will need to choose wisely which kind of collection you use to store your data in your C++ program. Okay, so once you set up your collection, it is going to store data. This is a good example of what a collection might look like. This is going to be a collection of integers that we have here. We want the ability to add elements, and adding elements is going to increase the size of your collection. For example, as we see here, we could keep adding, and this is going to extend the capacity of our container here. And I hate to break it to you, but I have built the box container class to mimic one of the standard collection types that we have in C++. And once we learn about that, you're going to see that you already know a lot of things about these collection types. So as we add new elements and we run out of capacity, we have the option to expand our capacity, and we can keep adding stuff. We want the ability to remove elements. So for example, we can target the 8 here. We can remove it. We can even remove elements that are identical. For example, if we remove 5s in here, we're going to start by the first one, we're going to remove the second one, and we're going to remove the last one. We could set up a bunch of operators. For example, we have the compound addition operator, which is going to add up two box objects, and we're going to end up with a new box object, which will have all the elements from all the box objects that we added up. We can see that right here. We had the ability to set up an addition operator, so we could add up two box objects and get a new one, as we see down here. And we were able to set up the box container class by wrapping around an array of types as we have here. And we went through the trouble to set up a bunch of methods that really manipulate this array. This is what we did. But as we said here, we will have the ability to use standard container types in C++. And we have a bunch of them. We have std vector, which is something that is going to look like box container. We have std array. We have std list. We really have a bunch of them. And we will have a chance to learn about them in this chapter and other following chapters that we will do after this one. Another key component of the standard template library is iterators, and iterators are pointer-like types we can use to navigate through our collections in a unified way. So for example, we could navigate from the first element to the second element all the way to the last element. We also have the ability to move backwards if that's what we need in our C++ application. And we are able to do that by using a bunch of built-in iterators for each kind of container we will have to learn about in this chapter and other chapters to come. So we can set up a begin iterator, which is going to be pointing to the first element. We can set up an AND iterator, which is going to be pointing to the element past the last one. So the AND iterator is not going to be pointing to the last element. It will be pointing to the element past the last element. This is really important to understand. Another key component is algorithms, and these are a bunch of functions we can use to manipulate our collections. Here are a few examples of things we might want to do through algorithms. We might want to sort our data. We might want to find something in our collection. We might want to copy data from one collection to another. We might want to fill our collection with a given value. We might want to generate stuff from our collection. We might want to transform data in our collection. We can really do all kinds of crazy things with algorithms. And we will have a chance to learn about a few of these in this chapter and other chapters to come. So this is what we are up against in a few chapters ahead. We will learn about the standard template library. We will have a chance to explore a bunch of containers. We will learn about a bunch of iterators we can use with those containers. And we will see how we can apply algorithms to containers and be able to do all kinds of crazy things. We are going to stop here in this lecture. In the next one, we will learn about our first built-in container type, which is std vector. Go ahead and finish up here and meet me there.